So in today's lecture, we are going to discuss the graphical analysis in kinematics, right? So you may write graphical analysis, right? First, I will discuss the displacement time graph or the position time graph, right? Position time graph. Listen one thing. If the velocity you think ds upon dt, right? Velocity is what? Ds upon dt. And this is nothing but this is the velocity, and ds upon dt is nothing but slope of st graph, right? Position time graph. For example, if this is the s and this is the t, right? S for position and t for time, right? If you think this is the graph, right? Or the graph may be the straight line, or the graph may be the curvilinear like that, right? S or t. Is it clear or not? Or you can make the graph like this. Fine. So if this is S and T and theta, for a straight line, this is a straight line. Straight line mean one line, one slope. Mean straight line, one slope. What does it mean? The velocity is nothing but ds upon dt, and it is equal to constant, right? Which is equal to tan theta, right? And therefore, if st graph is a straight line like this with positive slope, its slope is what? Say positive. So its velocity is positive and its velocity is constant, right? Like this. Because its slope is what? Less than 90, angle is 90 degree, slope is positive. So from this point to this point, from 0 to t, t1, the one straight line, one slope, and from every time from 0 to t1, any time, right, the velocity is constant, right? Listen one more thing. If you consider another line like this is the another straight line from t1 to t2, suppose, right? The st graph is again the straight line, fine, and its velocity over here, this is the straight line and this is the negative slope, because the angle is 90 degree, more than 90 degree. So velocity is constant and it is negative, right? Sometime this angle theta is given, right? Theta is given. And sometime the alpha, this will be given. So if you writing the v1 and the v2, right? So here the v1 is positive velocity and which is equal to tan theta. You have to write, because v1 is nothing but the ds upon dt. Here for this line, v2 is what? Say minus tan alpha. This is the negative slope and the negative velocity. Is it clear or not? For example, if you consider a different curve, for example, if this is the s and t graph over here, right? This is the graph. All right. If this is the graph, right, this is the point where the slope ds upon dt is what? Say 0. It means this is the point where, if you consider this the a point, at a point the velocity is what? 0, because the slope become 0. Before this time, suppose this is the t1 time, right? If you choose this point, right, suppose this is the b point, if you consider the tangent drawn upon this, right, the tangent drawn upon this, so its slope is what? Negative, because the angle is more than 90 degree. So at point b, the velocity is what? Negative. While if you consider the point c over here, here the slope is 0. When it is moving right, the slope, the straight line or the tangent over here, if you consider this is the c point, this angle is less than 90 degree. So at c point the velocity is positive. You understand this concept or not? Right? Before t1 the slope of the line is negative, then it becomes 0, then the slope become positive. So initially the velocity is negative, then slowly it is decreasing, it becomes 0 over here, then the velocity become positive. So the thing is that the slope of st graph give the velocity. The concept you can write, slope of st graph, right, give velocity. right? Copy this. So let's see some another example. Suppose this is the ST graph, right? This is the ST graph, and this is a straight line parallel to the time axis. The ds upon dt at every point is what? You will say the slope is 0, right? The slope is 0. So everywhere the velocity of the particle will be 0. Are you getting or not? Yes, Vranda. Do you understand how to find the slope of the line, or should I explain the slope of the line? Okay. So this is the, if ST graph is a straight line like this. So everywhere, what is the slope? Say ds upon dt is equal to what? 0. And therefore at every point the velocity of the particle is 0. You understand or not? Right. And if you take this is the S and T graph, the ST graph may be concave up like this, the ST graph may be, right, concave down like this, right? This shape is called the concave up, this is concave down. If you consider this is the point over here and this is the point over here, right? So initially suppose the point is this point. So what is the straight line? If you draw the tangent over here, this is the theta 1, fine. And if you draw the tangent over here, what is the theta 2? This is the theta 2. Is it clear or not? So you will see as the particle is moving, the angle theta 2 is increasing, right? Angle theta is increasing. So therefore in this case, what is happening? The velocity is increasing. Yes, Vanda, you understand or not? You tell. Right. The ds upon dt, if you consider this the t1 and this is the t2, this is the s and time graph. So at this point and at this point, right, if you draw the straight line or the tangent, this is the angle from the horizontal, right? You draw the straight line, this is the angle from the horizontal. So at this point va is nothing but the ds upon dt and is equal to tan theta 1, and at point vb tan theta 2. Since theta 2 is greater than theta 1, all right, theta 2 is greater than theta 1, therefore tan theta 2 is also greater than equal to tan theta 1, and tan theta 2 is nothing but the velocity of vb is greater than velocity of a, right? So in this case velocity is continuously increasing because the angle, that is the slope, is increasing. Since slope mean ds upon dt is increasing. Is it clear or not? While listen one thing, in the second case I have drawn, this is the first example, or you may write the second example here. Suppose this is the s and this is the time, and the graph is like this. If you draw the tangent, right, so this is the angle, suppose the theta 1 at point A, and if you draw the tangent over here, right, this is the angle, say theta 2. So this is theta 1 and this is what? Say theta 2. So as you see, right, the angle with the horizontal, that is the angle is decreasing. Theta 1 is greater than theta 2. Are you getting? If this is the point A, this is the point B, tan theta 1 is greater than tan theta 2. And tan theta 1 is what? Say velocity at A is nothing but tan theta 1. The velocity at B is nothing but tan theta 2. Right. So this is the velocity of A is greater than velocity of B. Right. So in this case, the velocity is what? Decreasing. Therefore, velocity is decreasing since, right, slope ds upon dt is decreasing. You understand this concept or not? You tell. Here the slope remains constant, therefore velocity is 0, right? The ds upon dt, which is nothing but equal to tan theta, is equal to 0. So therefore velocity in this case is 0, right? Copy this. Now the second graph is the velocity time graph. Velocity time graph, or in short it is called the VT graph, right? The velocity, right? Although the velocity is nothing but ds upon dt, also the slope of the dv upon dt give the acceleration. This is the acceleration and this is the velocity. All right, listen one more thing. If you consider this equation, ds is equal to v into dt, right? And if you integrate this, ds is equal to integration of v dt. So from t1 to t2, right, this is s1 to s2. So s2 minus s1, right, you will get this s2 minus s1 is the final minus initial position and is equal to v into dt from t1 to t2. What is it? Area under vt graph, right? And final position minus initial position mean total displacement. So if you want to find the total displacement, then you have to find the area under vt graph, right? For example, suppose we have the v and t graph like this. Is it clear or not? Suppose the graph is like this, right? From t1 to t2, right? If you see the area from t1 to t2, here at t1 the velocity is, suppose the instantaneous velocity is v1, here the instantaneous velocity is v2, and from t1 to t2 if you want to find the what is the displacement of the particle, so the displacement of the particle, that is the s2 minus s1, is nothing but you have to find the area from t1 to t2. Is it clear or not? Listen one more thing. The area of the vt graph is not its dimension, its unit is meter square. No, here the area of the vt graph, velocity is in meter per second and time is in second, right? So if you multiply by meter per second and time in second, right, you will get in meter. So unit will be in meter. Meter mean the displacement you will be getting if you found the area. This is the one thing. Now we comes to this point, right? This is the one point. The another point, the slope of the vt graph gives the acceleration. For example, right, if this is the v and t graph, right, and this is the straight line, the graph may be the straight line between the velocity and time graph, right, and graph may be the curvilinear like this, the graph may be like this, or graph may be right like this. This shape is called the concave and this shape is called concave down. It is concave up and concave down, and this is the straight line. If you consider the particle from 0 to t1, one straight line from 0 to t1, the one straight line, therefore at every point the slope is same, right? dv upon dt. dv upon dt is what? Here the slope is positive, right, because it is 90 degree, and if it is positive, the acceleration is what? dv upon dt is equal to tan theta, right, 0 to t1. All right, if the slope, the straight line is this from t1 to t2, the acceleration, you have to find this angle alpha. The angle is more than 90 degree from the positive time axis. So if you want to write the slope of this straight line, the slope of this straight line will give the acceleration, and it is minus tan alpha from t1 to t2, right? From t1 to t2, this is the tan alpha. From 0 to t1, right, it is tan theta, right? So here the acceleration is constant for, and this is also, this acceleration is nothing but tan theta, which is constant, right? It is positive and constant from 0 to t1, right? From t1 to t2, from t1 to t2, acceleration is again constant, but acceleration is negative, right? This is the A2. Are you getting this point or not, Vrinda? Okay, did you get this concept? The area under VT graph give the acceleration, will give the displacement, right? First copy this, then I will explain. So before explaining this, first of all, the slope of the line, slope of line, how to find, I am explaining so that you can better understand. Listen one thing, the straight line, suppose this is the y or x graph, the straight line like this, right, like this, the straight line, this angle made from the x-axis, theta 1, theta 2, theta 3, theta 4. You will see all these angle, theta 1, theta 2, theta 3 and theta 4 are all always 90 degree, right? If the angle is less than 90 degree, then the slope is positive, m1, m2, m3, m4. What is the slope of this line? Say tan theta 4, right? What is the slope of this line? It will be positive. The slope will be positive and tan theta 3. It will be positive and tan theta 2. It will be, the slope of this line will be positive and plus tan theta 1. Is it clear or not? All the angles are acute angle, and all for this all straight line, whether this side or whether this side, it does not different, right, makes a difference, right? The angle is, if the angle is less than 90 degree, the slope is what? Positive. But if the angle is more than 90 degree, suppose this is the y-axis and this is the x-axis, right? If this is the y-axis, this is the x-axis, you will tell, is if you consider this the straight line, from the positive x-axis till the straight line is achieved, this is the angle. This angle is greater than 90 degree or not? Yes. So its slope will be what? Say negative. How much negative? So if this is the theta, you have to consider this angle alpha, right? This, although this is the acute angle, this is the obtuse angle, but you have to take this angle alpha, and the slope is negative and it is equal to tan alpha. Is it clear or not? Whether the line is present this side or whether is this is the line, whether this is the line, does not make difference, right? This is the, suppose this is theta 1, this is theta 2, this is theta 3. All the angle, in this case theta 1, whether theta 2, whether theta 3, all the angle is greater than 90 degree, and therefore the slope will be slope is negative. How much negative? You have to take, this angle is alpha, suppose this angle is beta and this angle is gamma. So if you want to write down this slope, right, this is the m1, if you want to write down this m2, can you tell me what is the m2 for this line? Vranda, this is tan beta, the slope is negative, and you will write it is minus tan beta. And if you want to write down the slope for this line, the m3, the angle is greater than 90 and the slope is negative, and how much negative? Say tan gamma. Is it clear or not? Right, Vranda, you are getting this thing? Hello? Yes, yes. Are you getting this thing? What am I explaining? Right. So this is the positive slope and these are the line with the negative slope. First copy this. So now, if the angle is less than 90 degree, the slope is positive. If angle is more than 90 degree, slope is negative. I'm taking one example. For example, this is the velocity time graph. I'm considering this only. So I'm taking an illustration 0 to suppose the 10 second, and the velocity become, suppose this is the 50 meter per second. Is it clear? Initially, then the velocity decreases to 0 linearly, right, in the next 20 seconds, and at 30 seconds the velocity becomes 0. Is it clear? Initially the velocity is what? Say increasing, then velocity is decreasing and it becomes 0. This is the time t, right? So from 0 to 10 second, 0 to 10 second, if this is the theta, right, the angle is VT graph is a straight line and angle is 90 degree, less than 90 degree. It is less than 90 degree, yes, yes, it is like. So what is the acceleration? Here the acceleration is nothing but dv upon dt, which is equal to tan theta. And how much tan theta it is? Say perpendicular upon base. The perpendicular is what? Say 50. The base is what? 10. 50 upon 10, 5 meter per second square is the acceleration. So for 0 to 10 second, whether it is 2 second, whether it is 4 second, whether it is 6 second, every time from 0 to 10 second, one straight line, one slope and one acceleration, which is equal to 5 meter per second square for 0 to 10. You understand or not? Now it is 50 meter per second, then velocity continuously decreasing, it becomes 0. So it is what? So retardation. So 10 to 10 second to 20 second, 30 second. If you consider the slope, if you consider this angle is greater than 90 degree, so the slope of this line will be what? Say negative, right? This is the negative. And how much negative? If you consider this is the angle alpha, so for 0 to 10 to 30 second, the acceleration is dv upon dt, right? This you may write this then a1 a2. dv upon dt is the slope of the straight line and it is equal to minus tan alpha. This is the minus because it is 90 degree. What is the tan alpha? Perpendicular upon base. How much it is? Say 20. How much it is? Say 50. So 50 upon 20. So minus 5 by 2 minus 2.5 meter per second square. So the it is the retardation, or you can say the acceleration is negative over here, minus 2.5 meter per second square from 10 to 30 second. You understand this concept or not? You tell. Right, copy this. The same way I told here, if this is the theta, so acceleration is tan theta. If it is a2, the acceleration is minus tan alpha. That's it, right? Copy this, copy this. For example, suppose there is a train, right? If you consider the metro train, right, it starts from 0 velocity, then it accelerates, it achieves some maximum velocity, right? Then it will continue to move with this maximum velocity for some time, and for stopping to the next station, right, the velocity is slowly decreasing and it become finally 0. Understood or not? So if you make the graph between the velocity and the time graph, right, this is the v and this is the time t, right? Listen one thing, from 0 to t1, right, the velocity is increasing and the acceleration is positive, or therefore the velocity is increasing continuously linearly. Suppose the acceleration is positive and constant, so speed or the velocity, you can say, of the car is increased continuously and it become maximum. You understand or not? Tell me. After that, for some time between the two stations, it is not like that the velocity is continuously increasing, right? Then it will continue to move with the same velocity from t1, this is the t1, t2 and then t3, and then finally the car or the train come to rest at time t3. You understand or not? So you will say this is the accelerating phase, this is the constant velocity phase, and this is the retarding phase, right? So from 0 to t1, suppose the maximum velocity is 100 meter per second, and this is for the 2 second, right? This is 2 second, this is 5 second, this is 5 second, right? And this is 10 second, right? 10 second. This is the thing. So this is the VT graph, what we are discussing. If you consider from 0 to 2 second, 0 to 2 second, this is the theta. If you are asked to find the acceleration in this case, right, in this case from 0 to 2 second, what is the acceleration? The VT graph is given, so the acceleration is nothing but positive tan theta. And what is the tan theta? Suppose the maximum velocity is what? Say 100 meter per second. So this is the 100 and this is 2. 100 perpendicular upon base. So this is the 50 meter per second square. Mean the train accelerate from 0 to 2 second, right? 0 to 2 second with 50 meter per second square acceleration. Is it clear? This is the slope. Acceleration is nothing but dv upon dt is equal to tan theta, which is the slope, right? For example, now from t1 to t2, right, 2 second to 5 second, what is the acceleration? This is the acceleration in this case, this is the acceleration. Tell me, the velocity is constant or not, right? if the velocity is constant, the acceleration is what? Say 0. Definitely it must be, because this is the straight line. What is the slope of this line? Say 0, because right. So this is the theta. For the theta for this is what? Say 0. So acceleration is tan 0 is equal to 0. No acceleration is over there. Therefore, if the VT graph is the straight line like this, so no acceleration at this point. That is why the velocity is constant and it is moving with the 100 meter per second. Right, 100 meter per second from 0 to 5 seconds. Is it clear? Now the brakes are applied. The car slowly, or the train slowly reduce its velocity. And if you consider this is the linearly decreasing the velocity, it becomes 0. Right. So you will see this is the straight line having the angle more than 90 degree. So therefore its slope is what? Its slope is negative. How much negative? You have to take this alpha. So from 5 second to 10 second, the acceleration A3 is minus 10 alpha. Right. And what is the 10 alpha? This is 100. This is 100. And how much it is? Say 5. So 100 upon 5 minus 100 upon 5 minus 20 meter per second square. So for this case, right, when the car is retarding, right, here the acceleration I am writing the A3 is minus 20 meter per second square. Negative sign shows it is the retardation. Right. So in this way A3 you can write. From here to here, the A2 is what? 0. So this is the VT graph. Is it clear? VT graph, if the straight line is positive slope, the acceleration is positive. Right, the acceleration is positive, you may write. If negative slope, the acceleration is negative. If 0 slope, acceleration is 0. In this case also we have done. This is the straight line in VT graph with the positive slope, so acceleration is positive. This is the straight line with negative slope, so the acceleration is negative. Velocity is increasing, velocity is decreasing. If acceleration is positive, velocity is increase. If acceleration is negative, velocity will decrease. You understand, Vanda, this concept or not? Copy this. So listen, one more thing, one more concept is left. In the VT graph, right, as we explained in the ST graph also, the velocity time graph may be the curvilinear like this. This is the straight line graph. It may be the curvilinear like this. So if you consider this is the time t1 and this is the time, suppose the time, this is t2, right? So tell me, if the acceleration is at this point is a1 and acceleration is a2, so which is greater? A1 is greater or A2 is greater, or A1 is less than A2? How to find? Listen, one thing, as I told you, the acceleration is nothing but the slope of the velocity time graph, right? So at this point, if you draw the tangent, right, so this is the theta1. Is it clear? And if you, this is the straight line like this, and at this point, if you draw the tangent, this is the angle, right, the theta2. This angle you will see is increasing continuously. So at the acceleration a1 is what? The acceleration a is nothing but equal to the tan theta1, which is also equal to the rate of change of velocity, right? And at this point, if you consider this is the theta2, this is also the theta2, so the acceleration is tan theta2. Tell me, which is greater than, which is greater, theta1 or theta2? So theta1 is less than, I am writing this side, theta1 is less than theta2, so tan theta1 is less than tan theta2, or you can say the acceleration a1 is less than a2. In this case, the acceleration is constant because it is a straight line, only the one slope, but here the slope is increasing, so therefore the acceleration is also increasing, right? In the same way, this shape of the graph is called the concave up, right? The other shape of the graph may be the concave down. For example, if this is the velocity time graph, the graph is like this, the concave down. If you consider this is the point, suppose, right? So this is the initial angle, right? When it is moving like this, suppose this is the time t1, this is the time t2, right? The straight line is like this. So its angle with the horizontal is what? Decreasing. The angle of the, when you will extend this in the backward direction, right? This is the theta 2, right? This angle theta 2 and this angle is theta 2. Whether you measure the theta 2 from here or just you make the horizontal line, you can measure the angle theta 2. Initially, this is the line, this is the angle, it become horizontal, and the angle is decreasing. So if the acceleration at this point is a2, acceleration is a1, right? Theta 2 is less than theta 1, tan theta 2 is less than tan theta 1, the angle acceleration a2 is less than a1. In this case, acceleration is decreasing. In this case, acceleration is increasing. If the straight line was there, the acceleration was constant. You understand this concept or not? Vrinda, please tell. Yes, copy this. So read this question. In this question, the ST graph of the two particle A and B is given. This is S and this is the T. This is the particle A, this is the particle B, right? This angle is 30 degree and this complete angle is what? Say 60 degree, right? So what is the velocity of A? In the ST graph, the first I taught you the ST graph, the velocity is nothing but ds upon dt. It is nothing but slope of ST graph. You understand or not? What is the slope of the ST graph? Say tan theta. So yes, VA, this is the A making 30 degree. So is it tan 30 or not, you tell? And for B, for the B particle, what is the angle? 60 degree. So the VB is nothing but, right, tan 60 degree. Tan 60 is root 3 and tan 30 is 1 by root 3. What they are asking, the ratio of velocity of A to the velocity of the B. The velocity of A is 1 by root 3. It is root 3. So when you will find VA upon VB is nothing but 1 upon 3. This is the answer, right? Copy this. So read this question. In this question, the position time graph, the ST graph is given. This is the X and this is the T. How it is? This is increasing, then it is decreasing, then it becomes 0 over here, then it becomes negative like this, right? This is the plus 40, right? This is what? Say minus 20. This is 0 to 4 to 5 to 6. Is it clear or not? First part, the total distance. Listen one thing. The total distance, how would you find? Listen, there is a particle initial at x is equal to 0, then it moved to the 40 meter per second, reached to this point. Are you getting? Then it come back to the 0 position, then it come back to its 0 position over here. Are you getting? Then it become minus 20 over here, then it reached to the original position once again. Is it clear or not? So in this direction it travel 40 meter, then backward direction 40 meter, then downward direction say 20 meter, this is 20, then upward direction then 20 meter. So first part, what is the total distance cover? Total distance is 40, 40, 20, 20. 40, 40, 20, 20. 40 plus 40 plus 20 plus 20 is equal to what? 120 meter. Is it clear or not, you tell? Can you tell me what is the displacement? Listen one thing. The displacement is line joining initial to final position. This is the initial position, move up, down, down and on the same position. So it starts from x is equal to 0 and this is also the x is equal to 0. So what is the displacement? Can you tell? 0, right? And what is the total time? 0 to delta t is nothing but 6 seconds. In the third part, what they are asking? They are asking the average speed. Average speed. what is the average speed? Say total distance divided by total time. How much distance is covered? The distance cover is 120. And what is the total time it takes? Say 6. So 20 meter per second is the average speed. Is it clear or not? Now in the fourth part, average velocity. Average velocity. Tell me the total displacement divided by total time. What is the total displacement, you tell? Say 0. And what is the total time? Say 6. Say 0. So what is the average velocity? Here it is 0. Vrinda, you understand all the four part? Copy this. So read this question. In this question, a particle move in a straight line according to the velocity time graph is like this. This is the V and the T. Initially accelerate, velocity increases to 2 meter per second, right? And then it move with constant velocity. Then again the velocity is increase, right? And it become what? Say 10 meter per second. All right. Then it is what? This is the velocity. 10 meter per second. 10 seconds. Is it clear or not, you tell? Fine. 0 to 2 to 4 to 5 to 10. Now the total distance cover. The total distance. This is the velocity and time graph. The displacement or the position is given by the area under VT graph. So if you are able to find all the area, you are able to find the displacement. Is it clear or not, you tell? So the total distance is nothing but the area. This is the S. This is the area A1, A2, A3 and A4 you have to find. What is the area of A1, this triangle? 1 by 2 base into perpendicular. What is the perpendicular distance? Say it is 2 meter. What is the base? Say 2 meter. So the A1 is 2 into 2. Are you getting? I am writing this A1, right, is equal to A1 plus A2 plus A3 plus A4. The area A1 is nothing but 1 by 2, 2 into 2, right? So it is 2 meter. Fine. What about the A2? This is the A2. A2 is what? Perpendicular into base, right? This is 2 and this is distance is also 2 into 2 is equal to 4 meter. Fine. What about the A3? The A3 is this trapezium, right? This is the trapezium. How to find the A3? 1 by 2 sum of parallel side. This is 2 and this is how much? Say 10. This distance is 2 and this is 10. So 2 plus 10 into perpendicular distance. So this is 6 meter. And again this is the triangle, the A4. How to find the A4? Is nothing but 1 by 2 base into perpendicular distance, right? It is 25 meter, right? This is 25 meter, right? So what is the total area from the A1 plus A2 plus A3, A4, right? I am writing this side. Total distance, this is the first part, is nothing but A1, 2 plus 4 plus 6 plus 25, right? Thus 37 meter. You understand this question or not, or this part? Should I explain once again? First copy this. In the second part, the average speed is nothing but total distance divided by total time. What is the total distance cover? We have found the total distance is 37. What is the total time? 0 to 10 is equal to 3.7 meter per second. This is the second part. All right. Right. Third part. In which part the acceleration is maximum? The acceleration is nothing but dv upon dt. That is the slope. So in which part the slope is maximum? Listen one thing. If this is the VT graph, this is the one slope, theta 1. Can you find the tan theta 1 here? The slope. from here to here, 2 upon 2 is equal to 1. So this is the acceleration for this part. You understand or not? For this part, can you tell me what is the slope for this part? Theta is, this is the straight line. The theta is what for this part? See, 0. So the slope is 0. You understand or not? This is for 0 to 2, right? Then 2 to 4. What? The acceleration is 0 because tan 0, right? What about the between 4 to 5? 4 to 5. 4 to 5, this is the portion. So if you assume this is the alpha, right? So this is 8 upon 1. So here the acceleration is what? Tan alpha is equal to perpendicular upon 1. Are you getting this calculation? This is 8. And this is the base 1. And now from 5 to 10. 5 to 10. This is the retardation. Suppose this is the angle is beta. This angle is more than 90 degree. In this case, the A4 is negative. Right. This is the retardation and A4 is nothing but minus tan beta. Vanda, you are getting this thing? Yes, tell me. Tan beta. Tan beta is what? Say perpendicular. How much it is? Say 10. And how much it is? 5. So minus 10 upon 5, right? So A4 is minus 2 meter per second square. So this is the retardation, right? First copy this. Using this theta 1 alpha, right? You may write it is only theta, right? Alpha, beta, and for this A2 is 0. This is the straight line. For this part, this is the A3. You may write at this graph or not, right? Here I have written, right? Copy this. First copy this. Copy the average speed, then you can write the tan theta 1, tan alpha beta like that. So in which part the acceleration is maximum, you tell. In this part, what is the acceleration? Say 1. In this part 0, it is 8 and it is the retardation. So for 5 to, therefore it is clear from 4 second to 5 second, the acceleration is maximum. And what is the maximum value? Tell me. For this portion, 8 upon 1, 8 upon 1, right? And this is what? Say 8 meter per second square. So the maximum acceleration is from 4 to 5, it is equal to tan alpha. I am writing once again, perpendicular upon base, right? 8 meter per second square. This is the third part. Fourth part, retardation. For this portion, the velocity is decreasing. 5 second to 10 second. Retardation. What is the retardation? The A4. We have found it is minus tan beta, and tan beta is nothing but 10 upon 5, right? And this is minus 2 meter per second square. This is the answer, right? Copy this.